everyone, happy Thursday. Okay, so today our focus is to do some practice. Okay, this is a project. This is a project in King County in Washington State. Okay, so it's very similar to Brian's project idea. So this project try to predict the housing price. Okay, the real estate, the price for the new homes, but we need to study the existing homes. Okay, we need to study the existing homes and see which factor contribute, most to the price. Okay, those house have a highest price. What are the common characteristics of those houses? Okay, so let me share that with you. And also this practice is your next lab. It's your lab 4, but I won't release that the lab this week, next week, and will last after Thanksgiving. So you will have like 2 weeks to work on this because this one is a little bit complicated. Okay, why I say it's complicated? Well, let me put it this way. Every time I do those statistics, I do those building models, prediction, regression, interpreting the results, I want to kill myself. It's so frustrating every time. Okay, never works, just one shot. Okay, even you follow the instruction, I totally feel for you. Okay, so relax. In the module, you see I post a YouTube video, right? People from Azure talking about machine learning and the statistics, right? They made it so easy, but it takes millions of times, trial and error to get the best model. Okay, so when you're out there trying to establish the relationship, well, the real world is not a dreamland. It's not a Disneyland. You always have happy ending. Okay, so but that's also the beauty of the real world, right? Welcome to the adult world. Okay, so relax. Okay, I think the most important thing is to get the basic ideas for spatial analysis. Okay, so let's get started. That is also why I want to use today's class meeting to first go over the general idea of this lab, and then next week you will have a big picture and you won't get lost. Okay. All right, so let me start sharing my screen. Okay, let's see. Okay, that can also lend you some lights in your own project. Okay, so basically is this lesson from Learn ArcGIS. Okay, ArcGIS put it all together. So I would recommend you use ArcGIS, ArcPro to do this lab, but I will provide the open source option. I say open source, I didn't say QGIS or GODA or other specific software, because you need to use multiple open source software, but mainly that is GODA. Okay, so here, let's focus on ArcPro first. Okay, so basically is this King County. Anyone been to King County in Washington? Seattle. They have a lot of lake, right? So let me maybe first give you an overview where it is. Okay. Okay. So this is our Washington State. Okay, Washington State, and this is the King County. And you can see those dots, they're houses, they're existing houses. Okay, and then there's Seattle, I think it's here. Let me turn off. Yeah, So Seattle is here and Tacoma is here. Last year I was there for the cartography, the conference. Okay, and then if you plot those house data, you can see it's here. But if I change the symbology, okay, right click on it and then go to, you know, unclassified colors, for example, and then you have this housing price, where is that? Here, okay, and let's use a warm color like dollars, okay, like this. Okay. Let me change. You can see this data have some certain outliers. Okay, so you can see here in ArcPro, you can just see, you can immediately see the histogram, the data distribution. So you can see I have an outlier. Okay, totally, you know, mess this scale up. So in this case, you actually can drag this data all the way up. Okay, because you know most of the data concentrate in this area. So you can drag it up a little bit more and you see more variation of your data. Okay, so for example, I stop here. Okay, let me change the size of your color, size of the symbol. So template, okay, properties. Oh, this one is too large. Let's do 4. Apply. Yes, so you can see the sort of the distribution, okay? But of course, when you're close to the lake, you have those warm color, like yellow color, that means more expensive houses, okay? And those, you know, southern part of Seattle is more poor, okay, communities, and you will have a low house prices. Yeah, you know where our study area is, right? Okay. Okay. All right. Okay. So then you can see this lesson, this lab, you have many sections. Okay. Well, recall what we learned last time, the general steps to do a GIS project, right? So the first thing is what? Can anyone remind me? Brian?
Make a plan.
Make a plan. Yeah, yeah. After that, what's your plan? We are now making a plan.
Don't we have to come up with the, do we do make a plan and then hypothesis?
Yeah. So you guys get the general picture. You like the command general. Okay, you are overlooking the entire picture. Yes. Say we have a plan. Okay, the first thing you want to do is do what? When you get your, you know, get to the, you know, the first step in your work. Anyone?
Get the data?
Yes. Jane's question is easy. Okay, don't overthink my question. The first step after you have this rough idea, okay, I want to explore the housing price in Seattle, okay, in King County, Washington State. Okay, the first thing you get the houses, right? The data, the plots I just show you. Okay, and first you want to visualize your data. Right? You want to map things out. When you see the pattern, everything will get clear. Okay? So then the first step is to explore and visualize your data. So let's go there. Okay? So, well, you can download these, blah, blah, blah. There's no problem. And then here you need to perform this table join. Okay, to join the house, the price to your dot, the location. Okay, but you're familiar with it, so I will skip this part. Okay, specify the coordinate system. Okay, you all know this. Change the color. Okay, change the size, right? Okay, so then you visualize the data like what we just did based on price. Okay, and you want to understand why the pattern is like this, right? You see, oh, this place, have very high house price, and those places have very low house price. Why? What contribute to it? You can even do a hotspot analysis or something to highlight those high housing prices. Use your GI star, right? Okay, but here the focus is why? Why those places have high price? Okay, then that is our exploratory analysis, right? We want to understand why. Okay, in order to do this, okay, remember the first is to open the attribute data of this data set. Okay, so let's open it. Okay, open attribute table. Okay, so you can see in this table after you join the CSV file. Okay, and then you will have the price, and you will have those the factors people think that may contribute to the price. Okay, the market, the price they show in the market. Okay, if not, guys, in your project you need to find the data, but highly likely that data is based on a table. Okay, so for example, you will have those listing from, for example, from Redfin. Okay, do you check Redfin? I check it just for fun because I cannot afford it. Okay, so Redfin maybe give you this table. Okay, ID. Okay, and then you have another shapefile. Okay, that is your location, and then you also need to join the table together. So this table join is called enrich your data set. Okay, so here, enrich your data set, but in this case it's a little bit different. We call that geo enrich. Basically they calculate the distance to lakes. Okay, so that's different story, but you want to enrich the data, try to find useful attributes that can contribute to your final result. So you can see here, okay, very important. You open the attribute table, you need to understand different columns. What kind of data is there? Okay, what kind of data is there? If it's number, what's the unit? Okay, can anyone tell me where you can find those information? For example, the price is in dollars, it's not in Chinese yuan.
Wouldn't it be in the attribute table?
No, attribute
Some
table.
metadata?
Metadata, yes, score, Professor Lenore. Yes, metadata, okay? The place you download the data, you need to search for your metadata to see where it is. What does that mean? Okay, and then you are safe to join the table together to enrich your data. Okay, all right, stop me, otherwise I will just moving on. I don't want to move it too fast because I want you to make sure you understand how to do those projects step by step. Okay, all right, so you can see this may be the information you see on the metadata. Okay, on the metadata, there's a different, the explanation of your different fields. Okay, and here for different, like this condition. Let's see, this condition. Let's see here. You have this condition that they are numbers, right? What does 3 mean? Okay, so in your metadata, you will have this condition. You will have 1 over all the way to 5. Okay, 5 is very good, 1 is poor. Okay, you understand the data, then you can conduct meaningful analysis. Okay, all right, so this is the grade. Okay, This is mean. And the view, or you have the lake view, right? You have poor lake view, or you have fair lake view, okay? All right, then that is your attribute table. So don't skip this, okay? This is very important. When you map things out, look for metadata and then try to know your data, okay? Then for our purpose, right? We want to understand why certain house have higher price, okay? Then we explore, we call that exploratory analysis, okay? So the very straightforward way is to do the scatter plot, okay? How to do this in ArcPro? Let me close this, okay? All right, let me delete this chart. Okay, so this is our price, right? Okay, so you just need to right click on this layer, go to create chart, okay? So you can see you can have many charts, right? If you want to do a scatter plot, this scatter plot, but just between price and the other factor of choice. But fancy thing is you can do this scatter plot matrix, okay? So if you go there, okay, you can select what are the variables you want to include in this matrix. Well, price, maybe bedroom, okay, bathroom, square foot of living, lot, floors, waterfront. Oh, I think all of these, right? Great. Okay. Maybe year build, maybe not because it's a year. Okay. I can calculate, how old the house is. Let's just stop here. Okay. Square foot of basement. Okay. And then you can show histograms. Okay. You can choose show R square. Okay. You can show the linear trend. Okay. It's up to you. You can customize it. And then when you hit apply, you will see this. Okay, you can close this one. Let me move that up. Okay. ArcPro, I have to say, did a really good job, okay, for us to explore the data. So you can see you have this matrix, right? Okay. This matrix is between the variables you just chose. Okay, so you can see the first one is your price. Okay, this is the price, how price related to other things, other factors. Okay, and then to the top you have this the distribution of your price. Okay, I think, let me move it a little bit up. Okay. Oh, I cannot show this one. I cannot show this on the side, but I can show the relationship here. Okay, and those numbers, they are R square. So what is R square? Okay, you can see this R square. Oh, this one is the highest, living room, right? So what does that mean? That means how, how well this line, this linear regression, this line fit your scatter plot, okay? How close those scatters to this line. If you see, oh, those factors, those scatters, they are very close to this line, then your R square is very high. So this line, this linear model will be a good representation of the relationship between your price and your square foot of living. Does that make sense? I assume you don't have any statistics. If you know, please help me. Okay. All right, so that is how scattered it is. Okay, I want to use this example to show you. Okay, so for example, this is what? This is the bedroom. I think it's the bedrooms. Okay, how many bedrooms you have? So you can see, guys, this number is very small, right? You probably won't choose it just by looking at that number because it's just R square is 0.0. 0.1, sorry, 0.1. But guys, it's no hurt to just click open it to see this scatter plot. What do you see here, guys? What do you see? Something interesting.
There's a linear relationship.
There is a linear relationship, except this point, right? Okay, so you can see this outlier, I will say, totally mess things up. Data is ugly. Data sometimes is messy. Okay, so, well, I don't know why we have this outlier, but just one, right? You have very low house price, but you have many bedrooms. It doesn't make sense. Maybe this price, you have some error in your data, right?
Like maybe they wrote down the wrong price.
Exactly,
or-
maybe miss 0.
Maybe they messed up and they put like an apartment complex or a hotel in there, because what house has 30 bedrooms?
Yeah.
I know, right? So don't be fooled by those, statistics, those numbers. Okay, there's no hurt, guys, in your project to click into those matrix to see what's really going on. Okay, if it's just one data, maybe wrong, delete it, guys, delete it. How to delete it? You actually can click here, I think. Okay, and then let's see. Let me close this. Okay, I think it's somewhere. Okay. You select it on your table. Let me just open the attribute table. You will see it. Okay. You will see here, guys, I have one out of this many selected, right? Okay. And then you can switch to this show selected records. And then you can go there. Okay. You can zoom to. Where it is, I don't see. Do you see it? That's super weird. Let's see. Or flash. Oh, here we go. Right here, right here. Okay. I need to change my selection. Let me quickly change that to options, to highlight selection. Let's change this color back to this one. Okay. Yes. Okay, really small, right here. Okay, don't know what's that, but it mess up the relationship. Okay, so maybe we can just delete it. Okay, let's see. Bedroom 33. I think, Candice, you're probably right.
Probably it was just only 3-bedroom and accidentally put 3 because the
I think so, maybe, right? So here you can actually delete it. Okay, but when you delete it, don't forget to click on the save on the top. Oh, sorry. Here, if you delete it, there's an edit. You have a save on the top. Okay, for example, I delete it. Okay, and then you can see the save will be, activated. Okay, and then if you hit save, yes. Okay, and then now you go to your chart will be updated and you will see that number will change. Okay. So you can click, you can close this. Oh, let me move that all up. Okay. Okay, so still 0, 1, okay, but your scatter plot changed, right? Because that one, you know, dragged your scatter plot, you know, basically compress those scatters. Okay, down here you see they fit the line very well. Okay, but when you delete, after you delete that, you know, 33, the bedroom, you expand this scatter plot, it's not a good fit, right? Okay, so this is why I say data is ugly. Sometimes this exploratory analysis also can take a few hours, even a day. Okay, because sometimes you see outliers, you delete it, but still you cannot have a very good relationship. Okay, yeah, but the bottom line is, the guideline is, if you suspect certain factors that can contribute to your final result, we'll definitely spend some time on that, okay, to see why or why not they have good relationship or bad relationship, okay, with your final product. So this is the one tip I will provide to you. Okay. All right, good. So far so good. Okay, then I will move on to the second tip. Okay, so let's expand it. Okay, so let's find this, guys. Let's find this highest in our matrix. Hover over there, hover over the block, you will see it. Okay, that is between your square foot of living and square foot of above. So basically second floor. Okay, you have those two variables. They are highly correlated. And then when you click on this block, you will see like this. That is a good, decent, good R square, right? Okay, but do you want to include both square foot of living and square foot of second floor in your model or no? So in your model, you can see here the square foot of living. Let's see. This one is the square foot of above, right? The relationship is 0.37. Okay, let me put it this way, guys. I see Brian is tired. Let me put this way. You can see your price square foot of above is 0.37, right? Okay, it's not low. It's actually a positive relationship. Okay, and your square foot of living, that is 0.49. Okay, so when you choose, if you answer my question, what are the factors that contribute to the price? Okay, you will choose square foot of living because the R square is high. Why you say it's high? Why 0.49 is high? Why 0.45, or you don't choose 0.45, 0.37? There's no reason, right? Okay, they all high. I can set my threshold maybe any factors above 0.3. I can choose it because they all have a very good, you know, relationship. And you know, this bathroom, no. Square foot of living, yes. Okay, and the grade, yes, definitely 0.45, right? Okay, and then maybe square foot of above, right? Okay, how you choose? Why you want to, you know, just discard this one, but use the other one? Or why not use both? Okay. Why not? We use both. They both have, you know, fairly good, you know, relationship with your price. Why? Can anyone give me an idea?
To me, it looks like the square foot above ground doesn't independently have any effect. Like it's dependent on square foot of living space, which has an effect. So if you were to choose one of the two, I would choose the square foot of living.
Professor James. Exactly, guys. You have redundant information if you choose both, right? Square foot of living will be counted twice if you also include square foot above. Does that make sense, guys? Yes, so independent variables. You need to choose your independent variables in your model. So this one we call that collinear relationship. Okay, because your square of foot living includes square foot above, right? Or highly correlated. So in addition to the first column in your project, in addition to here, okay, you also want to explore other blocks, see whether other factors have this collinear relationship. So you basically count the information twice. You don't want to do that. Okay, I don't know whether you have learned something called PCA, primary category analysis, something like that. Okay, you can summarize the information you have in all these factors, right? Just to try to extract independent factors that to build your model. Okay, so basically this linear relationship at the end of the day, okay, will be like this. Okay. Okay. You will have this price. Let me use P, your price. You want to predict it, right? Okay, equals to a linear relationship. It's linear regression, basically. Okay, you will have a constant. Let me use maybe just constant. Okay, const. Okay, plus what is const? Let me show you. For example, this one. Okay, so you can see this this line is not just pass the 0, 0, this point, right? Okay, it's intersect when your x equals to 0, it intersect with y with certain number. That number is your const. So you can see in this case, linear trend, y equals to that number plus that small number times x. The 1131, that one is your constant number. Okay, we also call that intercept because it intercepts with y axis. Okay, all right. So here, let me finish my drawing. Okay, then the rest of it basically is you have the parameter b1. Okay, you have your first variable. Let's use x. Okay, for example, that is the square foot of living. If you want to include more, okay, I can plus the other one, B2. Okay, that is, let's see, maybe grade. Okay, B2 grade. Okay, that is your second variables, and so on. Okay, and don't forget, any model you will have this error. We call that, we use this Greek letter epsilon to represent this error. Okay, so because you can see when you build this line, okay, your prediction is not the real value. I mean, your real value is not exactly on this line, right? You have this, offset. This offset is your epsilon. and you want this error for all the data, as small as possible, right? That basically is your criteria to choose the best model. Does that make sense? Yun, does that make sense? Yes. So basically you have many choices of B, const, right? And then you plug in those data you know, and then you try to minimize the total error, and you can choose the best one, the best model. That is actually how you choose the best model. Brian, does that make sense? Okay, all right. Okay, so this basically is, in our slide is this slide, the OLS model. Okay, let me clear my drawings. Yeah, clear all the drawings. Okay. All right, so you can see this so-called linear regression. Okay, OLS. OLS is ordinary least square. So basically that error, I want to minimize that error. Okay, so you can see here. Okay, you build this model. This model, if you just have one variable, just one x, it looks like this. In this case, your A is your constant. Okay, and B, we call that slope, okay, or parameter of the x. And then this epsilon is your error. Okay, this error is the offset you see here. Okay, and if you want to include more than one variable to explain, to model your y, you will have more, B1, B2, B3, Bn. We call that multivariate regression. But they share the same idea. You want to minimize this error. Okay, all right, so this is the OLS. You can see, well, if this OLS, this error, can also help us to choose, to analyze, if you have this line, right, how close your scatter plot, close to that line, and you can calculate R squared based on that, right? Okay, so basically your R squared is 1 minus that error. Okay, I just put things easier here. You don't have to go into those details, but basically your R squared is the higher R squared, the better. Okay, means your plot very close to this line. Okay, very close to this line means the relationship between your x and y is very close to this linear model. Okay. All right, so here two things. One thing is you want to minimize that how you build your model, but when you have the line already, you can also use the errors here, okay, the offset here to choose, to evaluate whether you have a good model or not. Okay, that is two ways. Okay. All right. Let's come back. Okay. Right here. Okay, so you can see this scatter plot actually is very useful. Okay, definitely in your own project. Okay, spend some time here. Okay, for example, Brian's project, when he has the the location for all the kelp forest. Okay, you can plot, for example, the number of species or the size of the farm, right? Okay, or product, those outcomes with ocean conditions. That can be temperature, can be salinity, can be many things. Okay, yeah, okay, wonderful. So this is how you explored it. Let me clear my drawings. Okay, then very quickly, how to do that in GODA. Okay, so when you launch GODA, you can see here the toolbar and your map, they're separate, right? So here you basically input your file. So you go here, I will provide this shapefile to you. Oh, it's right here. Why? Okay, let me open it again. So yeah, okay, here we go. Okay, so you can see same data, okay, but how to do the plot, you see that here. Okay, scatter plot matrix, okay, and you can see you can choose your factors here. Okay, for example, you have price. Okay, you need to click on this small arrow to send that to the right. Okay, and let's see, square foot of living, square foot of lot. Okay, maybe grade. Okay, yeah, let's just include those four. Let's make it easy. Okay, and then you close this, you will see this. Okay, so the number you see here, I made a mistake last time. The number you see here actually is a linear model. That's slope. Okay, that's slope. So basically, for example, you have this price, right? Okay, you have this price and you have this grade. Oh, no, actually. Let's see. You have price. Oh, yeah, sorry. I should look at the first row, not the first column in this case. Okay, look, just focus on the first row, guys. You have this distribution. You can see in most part of the King County, the price is quite low. You don't have that beautiful bell shape, distribution, right? So that actually determine later we need to use the F statistics instead of your normal distribution. It's not normal. It's skewed to the left, right? Okay, so you can see those three plot. This plot is between your square foot of living and your price. Okay, so basically your price is always Y here on this row. Okay, equals to certain constant. Here we don't see constant. Okay, let me use C const. Okay, plus just square foot of living. Okay, and that slope, that B is 280.629. Okay, so this is your slope. Let me just use 280. Okay, and then that is the square foot of living. And this is the function of this line. Does that make sense? The number you see here, that is the slope. Means you have this positive relationship. Okay, if you see a positive number. And you see here, you have two stars. That means the slope after statistics, okay, the test, the hypothesis test, this slope, this number is significant. In other words, you can trust it. Okay, and the significant level actually is 99%. It's very high if you see two stars. Okay, but if you see just one star, where do we have one star here? We don't have one star here. If you just see one star, that also means significant, but not that confident. That is 95. You pass this hypothesis testing. Okay, but if you don't see any star, means you don't trust it. Okay, does that make sense, guys? How to use this chart? Okay, all right, good, very good. Okay, so then you can see, you can also, do this scatter plot, okay? This scatter plot is just between two variables. For example, my X will be square foot of living, right? That is my X. My Y will be price, okay? And then you hit OK. And this one will provide you more information here, guys. You can see I have the number of observation, right? the general R square, you see this number that is the same as what we got in ArcPro. Okay, so how fit this line is to our scatter plot. Okay, and then you can see your constant. Your constant of this line is a negative number. It's right here, you can see. It's a negative number. And then the standard deviation of this constant number, because they do this iteration, they build a lot of model and then try to find the best one. Okay, the standard deviation is this one. Okay, we want the standard deviation is as small as possible, because that means your the model, different model, they're constant. Okay, they're very stable, I should say stable. Okay, they don't have many difference between each other. Okay, and then testing, this is your t-test, this is your p-value, means this A is significant. Okay, and then this is your slope, the slope you see, right? Okay, and then this is the standard deviation of your B, your slope. Okay, and then t-test, that number, but what you need to focus is this p-value of B. Okay, all right, so you can see your p-value of B is also very small, means significant. You can trust this model. Make sense, guys? Okay, but I still don't know why they have 3 rows with different color. I still don't, I haven't figured that out. I need to be honest to you guys. I don't know everything. Okay, so that is your different thing. Okay, different variables, the information you can interpret from here. Okay.
Jing,
Yes.
how do you normalize the standard error? Because like the 4402 doesn't like mean anything to me by itself, but is it in relation to the constant? Like
that is when you build this model. Very good, James. That is when you build this model, whatever number intersect with y-axis here. It doesn't have any physical meanings. That basically you can read it as this. When your square foot of living is 0, what's your house price?
Mm-hmm. But in terms of seeing how the standard error, like a comparison of the standard error for the constant versus the standard error for the slope, like you see these are like relative to the values. How do you normalize it in a way to say like, oh, that's a good standard error, that's a bad standard error?
You can see, well, basically you don't have to do this. When they do the hypothesis testing, they will consider standard deviation and also to compute, to calculate this t-test, and then to generate this p-value. So when you have that score, that the score, is significant or not, that consider this one already in the equation. The listed here is, I think, it's a redundant information. Okay, but you don't have to interpret by yourself. I know, I get it. How do you compare? It's a good standard deviation or not standard deviation. Okay, or let me put it this way: if the standard deviation is very, very small, okay, highly likely your p-value is very small. Okay, and your model is significant because all the model, they all say, oh, B should be this number. And intersect should be that number. Does that make sense?
So it's really the t-test uses the standard error.
Exactly.
And then you go from there. Okay.
Exactly. Yes. Okay. All right. Very good question. All right. So this is how you do that in GODA. Okay. All right. So let's go back to our lab. Okay, so you can see we basically based on the scatter we see here, and we want to choose square foot of living because they have a very high R-square, right, to predict our housing price. And you see this outlier. Okay, you can delete it. Okay, And then we basically settle down with this number, okay? We look in the square foot of living, and then you see, you know, the square foot of living have a very good relationship with square foot of above, right? They have this collinear relation, so you don't want to include both in your model. Okay, so you basically just you know, leave it out and then just use square foot of living. Okay, then we can go ahead to build our model. Okay, linear regression. But in ArcPro, they call that generalized linear regression. Okay, because that consider your prediction, your Y here. Your Y can be something like price. Okay, that is a, you know, numerous number. Okay, that's just a number, right? You can put it on your ruler. That's a double type if you put it as data type. Okay, that can also, your Y can be some categories. Okay, so for example, that can be land use. Okay, for example, land use can be, you know, farmland, can be, you know, house, can be barren land, you know, some categories. Okay, or your Y can also be, you know, just, you know, right or wrong. Okay, yes or no. Okay, some categories like this. Okay, so that include all you can do with this model. Okay, to regress, to do the regression using your variables to explain the Y. Okay, so that's why they call that generalized. But if you just use price, number like price, or the variables like height, okay, or weight, right? You can, that's just called OLS, ordinary least square regression. Okay, so don't be overwhelmed. Okay, so let's go here. Okay, so you can see it's pretty straightforward. It's in the analysis. You basically search for generalized linear regression and you will see this one. Okay, so let's go there. Okay, analysis, go to your tools, and you'll go generalized. Okay, linear regression. So we want to use this one. Okay, the in the spatial statistics tools. Okay. The first time you launched it, it takes a while, but very straightforward. You now know what are the variables, right? Okay, you just go to input features. That is our housing, the houses here, X, Y, 2 points, okay? And dependent variable, what is dependent? That is your price. That is a variable you want to predict, guys. Okay, that is your target one. So in this case, we are going to choose price. Okay, if Brian out there to build a linear model to predict the kelp, the farmland, okay, here will be, you know, how many tons of kelp produced in that farmland. Right, Brian? Yes. Okay, so that is your target variable. And then down here, you will have many types to choose your model. So you can see that is what I talked about it. You can have this continuous value like your price, like how many tons of kelp. Okay, that can be a number, or binary, we call that logistic. Okay, so for example, types, basically, you have, you know, true or wrong, black or white. Okay, different categories. It's farmland or barren, like that. Okay, or it can also be certain count. Okay, for example, you have one species. Okay, in Santa Monica Mountains, you have, you know, 4 lines, mountain lines. Okay, in our San Gabriel Mountains, you have 8 mountain lines. Okay, those counts, you just have integers. You don't have other numbers. Okay, you don't have 8.5 mountain lines, right? You don't have that half mountain lines. Okay, that would be scary. Okay, so you can see different thing. We assume they follow different distribution. That is how you do your statistics. Okay, for this continuous variable like your price, we assume that follow Gaussian distribution. What is Gaussian distribution? That's your bell shape. Okay, but in this case, guys, when we plotted our price, it's not a Gaussian distribution, right? Do you still remember the histogram of your house? Okay, it's sort of like this. Like you have most house here, and you have very high number here. Okay, if it is a Gaussian distribution, you should see this. Let me change that color. You should see this, like this. Okay, equal size from your mean to the left or to the right. Okay, but this one is definitely skewed. This actually is a F distribution, but in our GIS software, we don't have that distribution. Okay, in this case, you probably have to do, some transformation. Okay, sometimes we go with this log, this log transformation that can transform your number to normal distribution. Okay, or you can, standardize, normalize your values. Okay, how to normalize your values? Well, your price, let me change back to red. Okay, your price will have some minimum number, the smallest one, right? Okay, and you have your highest one, max. Okay, how to standardize all the numbers you have for price? Well, here's your equation. P, let me use as standardized, SD, let's use SD. Okay, will be equal to, okay, like me, like a teacher, normalize your score. Okay, I will use, okay, your real value, the actual value you have here, okay, minus P mean, minus the smallest number, okay, and then divided by the data range you have here. So basically the max minus the mean. This is how you normalize your score, right? This is the teacher, some student ask me, Jean, do you like normalize your student score? No, I never do. Okay, so you can see then the guy did the poorest job will get what? Will get 0. That freaked that guy out, right? Okay, and then Brian did the best job, okay, will be the max. Brian is the max. Okay, Brian will get 1, the highest score, right? Okay, so that is the standardized. Sometimes if you, after standardize, you can also times, P max here, okay? And you will have your standardized score, right? And sometimes you will see when you plot it out, you will see the equal size to the right, equal size to the left, from your mean. Okay, but sometimes it doesn't work. Okay, so you need to think about other ways to transform your data. Okay, so OLS require your data, especially when you use those GIS tools, okay, require data follow this Gaussian bell shape distribution. So that also emphasizes again why it's so crucial. First thing first, to do that scatter plot, to do that histogram, okay, to see how your data is distributed. Okay, that is also why sometimes this model building process is so frustrating, because you know when you very quickly hit run, okay, it doesn't make sense. You can hit it, you can just go step by step, hit run, but at the end of the day, your model is useless. Okay, the reason is you don't know your data, and then your model will be a garbage. You just trash it, it's no use. Okay, make sense, guys? Any questions? Let me pause. Are we good? Okay, so that is also why I hide it, because you need to, you know, do many preparation beforehand, okay, in order to build a useful model. Okay, but I think it worth it. At the end of the day, for example, Brian opened his new business, okay, and we all enjoy the new seafood, okay, the seaweed from his farmland, right? It's I think it worth it. I like the seaweed salad. Okay, then you can see binary, you should follow its logistic distribution. Okay, this one is called Poisson. Poisson. Okay, I always remember this way, croissant. It sounds like a croissant. It's a poisson. Okay, all right. So anyways, and then you basically, oh, I need to choose the living, square foot of living. Okay, and then you can, you know, you can run. Okay, in the lab, you will see, I will build a model and I can run. Okay, so let's see. This one is, let me change the location. Okay, see, teaching for 23, lab 4. Okay, I have data. Let's do shapes. Okay, so let's see, go here. You can save that as shape file. Okay, let's see, OLS. Okay, between your price, okay, and your square foot of living. Okay, save. Okay, and then, well, here at this step, we leave this one blank. Explanatory distance features. Okay, because you can see our model may be way too simple, right? Because you know people like living, you know, near to water. Around the lakes, you have a higher price. So it's nothing. Maybe in Santa Monica, you just have one bedroom, right? Or a studio have the same price as the one in the valley, where they have like 3 bedroom, 2 living room, 3 bathroom. Right? Okay, but here we keep it simple. Okay, let's hit run. I just want to show you what are the output. Okay, so when it's done, you will have this warning distance. Okay, basically you need to project it. Okay, I didn't project it. So using coordinates, the degrees, but make sure you project it, you don't have this warning. Okay, and then you can open the history, you can rerun this model. Okay, but here you can see, open history. Okay, so you can see here. Okay, you can, if you double click, you can rerun this model to, you know, refine your model. Okay, so okay, so then you have this, right? Okay, you have this OLS, square foot of living. So let me uncheck this one. Okay, so you can see you have the same dots. Okay, let's just first see see the dots first. Let's zoom out. Ooh, I have a lot of data. Okay, so let's change. Okay, let's change the size a little bit small. Okay. Oh, need to go to the symbology. Okay, and then let's go to primary symbology. Do I have a template? Classes histogram. Okay. I think I can change them all. More. Format all the symbols. Okay. All right. And then here, change that to maybe 2. Let's make it smaller. Okay. Okay, and apply. Let's change the base map because this one is too bright. Dark gray. Okay, anyways, maybe I change that to small. Let me change it a little bit larger, symbology. More format. 3, maybe 4, apply. Okay, all right. Okay, so what does the color mean? The color actually is standardized residual. What is residual? Let's go to our slides. Residual is this error, okay, for each point, So if you see the standardized residual, that standard deviation is very high, that means your model did a bad job to predict the value of that point. Does that make sense? Okay, so let's go back. So for example, you can see around the lake, I have many those, you know, blue, like sign, this color, right? That means that's positive. That means my model under predict the value of those house. Okay. In other words, I have this regression line, right? Okay. My real value is here. It's way above this line. And you can see the offset is always positive. And when you standardize it, okay, you will have very large positive standard deviation. Okay, that means if you see positive standard deviation, that means your model underestimate. You estimate the number, the price should be here, but the real value is here. Does that make sense? Okay, you can also verify here, open your attribute table of your output. You will see here, I have my residual, right? Okay, you can sort it from descending, and let's see. Let's select them all to see what are the values here. Okay, so you can see that is the data I selected. Okay, those values. I need to change the color again. Option, change that to yellow, and you will see them. Okay, so you can see those are the numbers, the dots I selected. Okay, yeah, the yellow part. Okay, so you can see close to the lake, I underestimated. Okay, so that is why when you go to, you know, your analysis, your tools. You can go to this history, or on the top somewhere you have the history. I don't see that now. But let me, oh, here, your recent, okay? Generalized linear regression. And then when you input your features, house, XY 2 points, right? And here, that is my price. Okay, this one is your square foot of living. And you can see here, that is a place you want to choose distance to lake. Okay, the distance features. Okay, so in the lab, I will provide you this lake and pond. Okay, so basically that is the two lakes you see here, lakes and pond. Here, the two lakes you see here. Okay, how close to those lakes? You can also include this one, this bay. And you choose that here, and I will include the distance to those lakes and ponds. And then you rerun that again. Okay. Shapes, yes, okay. So that is OLS with distance to lake, okay, and price living, square foot of living. Okay, and let's hit save. Okay, then you hit run, you will see different. Oh, adding to the queue. Okay, it's running. Anyways, I think I have that here. Okay, distance to lake. Okay. Okay, so you can see in this case, guys. Oh, it's coming. It's coming, but I don't want to show. Come on, come on. Why it's so slow? I shouldn't brush. Okay, anyways, you will see the problem solved a little bit. I think I'm freezing again. Do you see I'm dancing? Okay. Anyways, let me stop share. Okay, I'm back. Yes, so let it run. You can see this process take a lot of, computer memory. Okay, the processing power. So be patient, guys, especially when you use Citrix. Okay, you just use Citrix to use ArcPro. That may take, maybe a few minutes. Okay, be patient. Okay, be patient. Okay, so that will solve the problem a little bit, but not all the the bias, in terms of geography. Okay, because what? Because let me share the screen with you about this. Okay, you will see certain area. It's coming or no? Let me quickly change it, okay? And you can relax. After this, we can stop our meeting and we can continue on Tuesday, okay? Don't worry. I want to get it as clear as possible. Format other symbols.
Question, meanwhile, when you said solve the problem, does that mean like you meaning that we minimize the error?
No, you don't have the bias to the lake. You know, in the previous model, the normal OLS, constantly around the lake, you have higher residual, right?
Yeah.
You want to solve that problem by considering the distance to lake.
Mm-hmm.
Okay, does that make sense?
Because the distance to the lake was
It's a contributor to your house price.
and we didn't consider that in the beginning, so that's why those parts were underestimated, so we're just solving that problem.
Exactly.
Okay.
Exactly. You got it, right, Yun? You got it. Okay. So you can see this is the output. You can see it solved the problem a little bit, right? But still, for those areas, you still have very high residual. You still underestimate it, right? Okay. And then compared it to the normal one. This is the normal one. Okay, you have more. You basically solve a little bit. Okay, well, why? Why is it like this? So you can see if you take a look at it, right? That those residuals, they're by regions, isn't it? You can see, well, I can group them by just looking at those residuals. Around the lake, those places, let me annotate. Here, guys, I want your attention. You can see those green color. They're normally just by the lake. Okay, maybe move it here. Right? They're very close to the lakes. Okay, and those purple means what? Means you have this negative standard deviation. So you have this regression. They constantly below your regression line. You overestimate it. Does that make sense? You overestimate. Your prediction is here, but your real value is here. Okay, all right, yeah, James got it. Okay, I see at the beginning he was thinking, yes, okay. So you overestimate it, but you can see across the region where you constantly, the location, the region, where you constantly overestimate your house price by using that very simple linear model. To the south, right? This is another category. Okay, if you've been there, actually Seattle, King County have this segregation. You know, many cities in US segregated. Okay, well, this county is segregated. Well, here you have your urban area around this lake. Okay, Seattle basically is here. Okay, Tacoma is here, it's down here. Okay, but to the south, the suburbs and less developed area. Well, common sense, different factors contribute to those house price. Basically, your study area, guys, is not homogeneous. It's not uniform every place. You simply just use square foot of living can explain all the price, right? If you work for the the real estate, you sell houses to people. The house in, for example, Santa Monica, maybe people value what? The distance to ocean, to beach. They don't value, how large the house is. Right? Okay, but if you go to San Fernando Valley, for example, people will value what, Brian? Maybe
How close they are to me?
right. Maybe how close, for example, a Korean community, right? How close that to a Korean grocery store, okay? Right? Or closeness to a park, okay? So different location, you may have different factors, okay? Then that will make more sense to build different model to different region, right? Okay, so this is in different region. So this is the basic idea, okay? We want to learn this geographically weighted regression, okay? So when you build a model, actually it's not, let me present it, okay? When you build a model, we don't just build one model that, one size fits all. We actually build 2,600 models, okay, in the King County. Okay, so you can see here, your prediction, the Y become YI to certain location. I don't know the location I want to predict. Okay, then how I build this linear regression? Where are my training samples? It's just within the neighborhood of my target. Okay, so let me draw. So for example, your house is here. You want to predict the house value here. I just use the nearby location. Use their living square of foot, square foot of living, square foot of living, or how many bedrooms, or, distance to park, distance to grocery store, the size of the lot, right? Those factors to build this linear model just for this location. So this I basically is location. Make sense? Okay, and then for different location, you will have different B. You will have different B. Okay, so this is called geographically weighted regression. Okay, but you can see the key thing here is to define your neighborhood, right? Javi is here. Well, Javi, that is your spatial lag. Okay, but in this case, we use this method. We use different model. We use different kernel, guys. It's similar like your kernel density. Okay, for example, you can use this Gaussian, this bell shape to define your neighborhood. You can also define the contribution of your neighbors. The further they are, the less contribution to your model, right? Okay, so basically the height of this kernel is your weight, is your geographic weight. Okay, so you can see the closer they are, they have higher weight to this unknown location. Make sense? Okay, and then totally up to you which shape of the kernel you want to choose. Okay, that basically is when you get further and further away from your target location, how the weight change. Okay, so for example, I can use those two. This one is the weight have this continuous decreasing trend. Okay, but this one, you basically just have a neighborhood. Okay, within my neighborhood, say 1 mile buffer around me. Okay, they have the equal contribution to me. But if you're outside this buffer, contribution decrease to 0. Okay, so that is different shape. That is how you choose the shape based on how you want to build this model. Okay, how you consider the contribution from your neighbors. Okay, so you can see here, let me clear my drawings. Okay, let's go to our ArcGIS. Okay. Oh, no. I want to go here. You go to analysis. You have this GWR, okay, geographically weighted regression. Okay, same thing, right? Okay, so let's go here, X, Y 2 points. And then dependent will be your price. And the model type will be linear regression, right? Because its price is, you know, the continuous. And then you want to include square foot of living. Okay, same thing. But you can see here, you want to specify the neighborhood type. Okay? If you expand it here, you can choose the number of neighbors, how many neighbors you want to consider, or you choose this distance band. Okay, whatever, doesn't matter how many neighbors, I just consider the distance. Okay, so if you choose this one, you can see neighborhood selection method. You will have this golden search. You will have this, you know, manual intervals. Okay, you will have user defined. Usually, you will find this golden search. Okay, because it's tricky actually to choose your neighbors. Okay, this one is like a default choice to, you know, optimize the choice of your neighbors. Okay, and then let's see here.
What you say golden search was?
It's a default. It's a like optimized method. Can guarantee you have the best sets of neighbors to predict your target.
Okay.
Basically, in other words, if you don't know, just choose golden search.
So just I guess like an automated by default
Right.
standard
Right.
or something.
Exactly. So here you can choose your neighbors. That's also very subjective. Well, in the tutorial, they ask you to choose 50. Okay. And I forgot maximum. Looks like no, I forgot. Maybe let's do 80. Okay. But if you expand, you know, additional options, you will see this one. This is your kernel. So you can see you have your Gaussian, you have your bi-square. Here, ArcPro just have those two types of kernel. Okay, you can choose Gaussian, that's the bell shape. Okay, and then when you hit run, that will run the model. So I won't run because I ran that already and it take away a lot of time. So you can see first, you will have this prediction. Let me close this. This is GWR. Okay, and they will give you these charts. Okay, come on. You can see the overestimate. Later you will see overestimate in this area, in the southern part of the area, actually got better, but still not this place. I think we need to consider both the lakes and also the geographic weighted regression. Okay, but when you see the distribution of the standardized residual, this is a chart, you will see the mean is more or less at 0. So that means what? That means your model not just, you know, over predict or under predict. It's pretty neutral. Okay, for certain predicted house price, your standard deviation is neutral. They have both ups and downs. You don't constantly over predict the pricey houses or underestimate the very low housing price. Okay, so let's compare this one to the normal one. Right here, OLS, right? Okay, let's compare that to this one. You can see change a little bit, but still it's not very good. Let's see the distribution.
Professor Jing,
What?
Did you say we were considering the distance to only?
Say that again?
Did you say we were considering the distance to only one of them?
Oh, the distance to the lake, right? Yes, I need to compare to that one. Let's see where it is. Yes, let's go this one. Okay, this is the evaluation distance to the lake. Okay, and this one is geographically. No, I shouldn't open this one. I should open the normal one. This one. Okay, let's see. Okay, so this is the one. Sorry, guys. Let me clear the drawings. Okay, so you can see this one. You can see for the pricey house, this area. Oh, annotate. I have more above 0. Oh. Right? So you have more pricey houses, you get, underestimated. Let's compare this scatter to this one, OLS, no, GWR. This one, yes. Okay, so this one, let's open the same plot. Oh, no. Predicted residual. Oh, I should go to this residual. Maybe something goes wrong here. Okay. Let's see. Square foot of living. Where's my GWR? This is GWR. GLR, sorry. GLR, GWR. Maybe I should run it, sorry. I didn't see that here. Okay, so this is all the GLR, not GWR. So let me run it. I can stop share. You will see. Well, anyways, let me share here. Okay, because I see it's getting late. Okay. Oh. All right. Okay. So you will see after you run GWR here, the higher residual will become smaller. Okay, so basically what we want is for all the housing prices, okay, you have equal size, under predict, over predict. Then for the whole area, you don't have, the bias. That is what we want. Okay. All right, so you can see the residual here. Well, for the lower price, that's also very good. You can see the residual is very close to this 0, right? But when you go to the pricey area, this scatter plot is more spread out. You have this like a trumpet, this shape. This also not good because, your model become unpredictable. Right, your model is not good for those pricey houses. So that is not what we want. The ideal shape for this plot will be just like this, within a very narrow band around this standard deviation, the 0 right here. Okay, so that is a very, very good model. You evaluate it like this. Okay. All right, so that is GWR. So let me go to my slide. Let's see what else. Yeah, I think that's it. That's it. Okay, so this GWR, the basic idea is for each location you want to predict, you build a separate model. And then you can use the best predictors to build this model, okay, or to choose the best bees, okay, to predict the location you want to predict. Okay. All right, so let me stop share and I will hit run in my message this evening. When I sent out this recording, this link, I will include that chart, that comparison. Okay. All right, so this will be our lab next week, not this week. This week you focus on the proposal, but I just want to use this example to give you a heads up. This modeling, choose can take some time, okay? So be patient. And maybe at the end of the day, you still don't have the best model, but choose the best among all the models. Like Einstein, when his teacher asked him, Einstein, where's your, like a carving thing, the work he done? He just choose a very, not very good work, but that is the best he can do, right? Sometimes the model building have the similar, thing. You just choose the best, okay? That you may be limited to your data, limited to the relationship, because our geographic world is complicated. It's complicated, okay? So this is, I would say, the most challenging part for the entire semester. Okay, I hope you take it easy, okay? And also be patient when you choose your model. Okay, you want to study your data, really understand your data. That actually can speed up the the process. You choose the best model. Okay. All right, so I think that's it. That's it. Okay, so next week we just have one meeting on Tuesday. I will use another real example since we finished the models, and you know that already. I will use another, for example, let's use maybe election, okay, to predict the why, to explain why certain area you have higher turnout, certain area you have lower turnout. Okay, let's brainstorm what other the factors can contribute to that. Okay. All right, so that is our Tuesday. Otherwise, have a happy and healthy and safe weekend. Okay. All right, bye guys. If you want to talk about your project, please stay. Otherwise, I will see you on Tuesday.
Good night.
Bye.